Hi everyone, good evening guys. Hi everyone, good evening guys. Okay, so assuming that I am live, welcome to this important series which we are going to do. And thanks to the IMS team that we are going to conduct a master class series. So warm welcome to everybody. Uh, Before we get into the details of it, let me uh, inform some of the guys who might not be aware of it that GATE has come up with the new paper on data science and AI. If you see this on my screen, right? So GATE has added a new paper on data science and AI. What is the interpretation of it? Just like we used to do electronics or electrical or core engineering GATE paper, GATE has given some opportunity in terms of computer science and IT people, and also an open opportunity to everybody who wants to pursue a career in data science. And I think I have been telling this for many years. I started telling since 2015 that data is the new oil in the market, right? So, given the immense opportunity data science brings in anybody's career, this is a golden opportunity to grab with both the hands. And if you're not aware, you can visit the IISc website. So, IISc Bangalore is going to organize GATE for 2024, and data science paper is going to be one of the new paper. Okay. Good evening, guys. Okay. So now let me quickly break our the master series. So we have planned 4 sessions under this series, as you can see on my screen. So we'll start with the linear regression part 1, which is going to be the most important algorithm and the most easy to understand algorithm for anybody who wants to do, get a sense of machine learning based algorithm. This is something even computer science and IT people already being taught, right? So that's going to be our foundation for our master series, and it is planned as per the general understanding that it is a good algorithm to introduce everybody to the data science, right? So that's something we are going to cover in part 1, part 2, and part 3 and part 4. So we are going to have amazing 4 sessions of 1 hour each. Today we are going to have the first session. The second session will happen tomorrow, and then the other two will happen the next weekend. Same time, same place. Okay. Uh, Now let me quickly introduce myself before we get into more details. So guys, my name is Akash Pushkar Charan. You can call me APC or Akash. I'm an IIT Kanpur alumnus. I am so happy that when I was trying to pursue my masters, I had to take an interdisciplinary program to do data science, right? And I did my masters from IIT Kanpur Industrial Management Engineering Department. So there, my major was industrial engineering, but data science was the horizontal. So I was applying data science in supply chain, marketing, a bit of finance as well. That was the interdisciplinary course. And what has changed from the, when I did my master's in IIT Kanpur till now, is that now they have added a dedicated paper for you so that you can directly go and pursue data science as a formal course. You don't need to take it like major or minor. If I talk about my professional journey, so I have completed close to 8 years of experience. Mostly it's in supply chain. I'm a lead data scientist working with Accenture Strategy and Consulting. I have delivered close to 15, 20 plus of projects across industries. I have been doing also a lot of GATE sessions. Uh, and that's where, if you look at my experience in training and mentoring, comes close to, more than a decade. And I feel that given my exposure to GATE as an exam, right? I've been teaching GATE for electronics people over the weekend, and my BTech is in electronics, right? ECE or ET, right? And then I have been doing data science, industrial data science for close to 8 years. So that's where I come in the picture to, guide you with the best of my understanding in this new paper. And as a matter of fact, we have already, launched a batch trying to, discuss the machine learning and strategize for about the first paper. First paper is always tricky and also very much in terms of opportunities, because generally GATE will not come up with a very difficult first paper. So those who are targeting 2024, I think it's a golden opportunity for them to pick this GATE DA paper, and it doesn't matter you are from what stream, except few streams there are some exception, and you can go into detail, but most of the engineering streams can apply and can write this exam and prepare for it. If you talk about my credential in training people, so I have close to 30,000 plus people I have trained in last so many years, right? And on parallel, I have been also mentoring and training people to take a transition from IT to some other software side or some other core engineering to data science, and that's where I have helped close to 5,000 plus people making a transition into data science. And if you look at the overall picture, my dear, right, this is not an opportunity only to do a master's. Even if you pursue as a career after bachelor's, this definitely gives you a good platform. And let me quickly send the, uh, hold on, yeah. Let me quickly share the LinkedIn ID. Maybe team can place it in the chat. I do talk about data science gate on there, so you can always try to visit me if you wish to and follow me there. Okay. Now, quickly, let me move on to the next part, which we are going to cover. So far, so good, guys. Any question, any comments, any reaction? GATE has come up with a new paper. I hope some of the guys must be aware of it. Okay, so see, before we get into the first session on our simple linear regression, it would be quite imperative for me to give you an understanding of machine learning. Okay, so rather than going into the textbook definition of machine learning at first, I would like to introduce machine learning to the guys who are going to watch this session with a simple example of a newborn baby, right? You must have seen a newborn baby. Now, in this example, I am going to interpret. If you look at a newborn baby, right? Uh, the baby, when it gets born, right? The baby tries to learn to speak certain words, the broken words like ma, papa, right? And if you look at the language, right, that's where I will try to draw your attention. If you look at the language the baby is going to speak, that majorly depends on what is the environment the baby is living in. So let me take a very simple example. If you look at a newborn baby, and let me also ask people who are in the session, generally how much time a baby takes to speak certain words, not the sentences, the words. And if you look at that, okay, anybody, what do you think? How many months it takes a baby to speak, 4 or 5 words? I'm looking at the chat. Anyone? I have felt, and definitely you can correct me I'm wrong, but I have experienced that generally 11 months to 15 months a baby take to speak certain words. And if you focus on the journey of a baby speaking certain language, it majorly depends on the environment the baby lives in, right? So I'll take a simple example. If an Indian baby, like an Indian parents, right, and let's say after the marriage they move to, let's say, US, right, or UK, any other country, and there they are going to have their baby, and the baby is trying to get the upbringing in that environment. Suddenly you will feel that if the parents are also talking in the similar accent, right, because of the environment, right, baby will try to pick certain languages. One will be their native language. So let's say the person is a Telugu person, so the native language baby will also pick. And because of the environment, right, so if you look at the environment, right, so their kids will be talking in their native language, so they will be talking US accent language. Even without baby is being taught explicitly this particular language, baby will pick this language. You understand? So what has happened, right? A baby who is coming from Indian parents they might be speaking Telugu language, right? And then the baby is also picking the US English. So somewhere the baby is getting trained, right? If you take it like a baby as an object, which we should not do, but definitely if you try to look at the machine learning, definitely you are putting an algorithm there. God has put a really complicated and sophisticated algorithm in form of a brain that gathers the data, right, which the words being thrown at the baby, and the baby tries to, catch some of those words and adapts to that behavior. If you send that baby to, let's say, some different country, like in Asia, if you send the baby to China, chances are very, very high that they will start speaking Chinese words. And that's how people pick language, isn't it? That's number one thing. That's a something which you have seen in a lot of machine learning algorithm that, and that we will diverge on that later, that when you try to give different data, the same algorithm will behave differently. Because because if you look at the, unlike any software or program, machine learning is not like a set of some logic and flows and business rules. It tries to get the insights pattern from the data, and if you keep changing the data or the environment where the model is being trained, model will adapt to the new environment, and the results will also differ. Okay, so that's a very simple way of looking at machine learning, guys. Now if you look at machine learning, generally people think that machine learning is some rocket science, and that's where I would like to try to bring it to a very simplified level. If you look at a simple website called Google News, I'm damn sure you must have seen Google News, everybody. If you look at Google News, and I'm going to show you one screenshot, just give me a sec, that is coming from the Google News website, which I've annotated. If you see, there is a story which is saying, explain why Afghanistan embassy has closed its operations in India, right? Look at this. I think everybody has seen this uh, once in a while. If you visit any Google News or any similar kind of portal, you will see that a lot of news articles have been clubbed together, and then there is a parent information, right? More like this is the parent news article, and then you will see that there are a lot of similar news article clubbed together, clustered together, and if you look at the context, it's all in the similar context. Now if you look at this particular example, you might be thinking there's something happening, and if you try to understand what's going behind the scene, then Google News, if I can give you very high level 2 3 steps, what Google News is trying to do here, that it tries to all the news articles, fetch all the news articles from different news portals, then try to make sense of it. So they summarize it, get the sense of the news, right? Summarize these articles. And the third step can be clustering these news into one, clustering them as per the relevance. Make sense, guys? So that's exactly what's happening here. And nobody is doing it manually. Let me give you that idea. If you go to Google News in India, US, and different country, you will see that it is being done with an amazing accuracy of somewhere 99%. This is, if I put in machine learning algorithm, right, this comes under the category of unsupervised learning. So machine learning has brought 4 categories. One of the categories is unsupervised learning. And within that, I don't want to, or I'm not going to get the details of like the Google News algorithm, how does it work and all, but high level, if you say, it works on the clustering, right? Clustering is an algorithm, which we will see later, okay, in some different master clusters, right? So if you look at this, then definitely you get an idea that machine learning, ML, has broadly divided into, as I mentioned, that 4 categories or 4 big areas. One of them is supervised learning. One is unsupervised learning. Then we have reinforcement learning. And then there's one more, which is not more exposed, is known as semi-supervised. Perfect. Our masterclass series, which we are going to do, will focus on supervised learning. So, from from here on, I'm going to give you cool examples from supervised learning and try to give you intuition behind it. Okay. So if you look at this, this whole series, which we are going to cover in coming this week and including the next week, we are going to focus on supervised learning. Now the question comes, what is supervised learning? Anybody? Anyone? Okay. So supervised learning is an area of machine learning where, model is going to have the inputs, which we generally say in layman language, X variables or features, and you're also going to give the output, right? That's correct. Very good, Aditya. Output. And you can say in machine learning language, levels. So that's what you mean supervised learning, isn't it? Unsupervised learning will have only the inputs, right? Only the inputs. Means you have all the features, but you don't have any labeling to that. So if you give different fruits to a like a monkey or chimpanzee, right? On the basis of the color, different shape and size of the fruits, right? That monkey will try to select the banana out of it. Have you seen, right? Monkeys like bananas, right? Everybody knows this. So even if you give a fruit basket to that monkey, it will have apples, it will have oranges, it will have banana, right? So definitely he uses the monkey uses these the shape, size, color, these object characteristic, and tries to group it. Okay, so he will pick all the bananas, right, guys? And maybe he'll not take the mangoes or apple, depends on the monkey also. I'm not trying to put bananas on the monkeys, right? Monkeys can also have a different choice of fruit, but definitely that is what unsupervised learning is, right? So again, if I go back to my example, if you look at these news articles, right, definitely you have used some text mining or natural language processing tools to understand the context or the sentiments of the news, right, and then try to club it, right? There is nobody telling that, okay, all these will go into one bucket, the other will go to the bucket two. That's the key difference between supervised and unsupervised. Reinforcement and semi-supervised, is something you can delve further. But just to give a quick idea, reinforcement learning is all about how to, if you have seen any robots or any gaming bots, right? They work on the reward, right? If you do all the actions correctly, you will get bonus points, you will get some rewards. Or if you are missing on those, you are doing some mistake, you will be penalized. So that way, the model learns, right? And if you look at any these the AI bots or any robots, right, they try to learn using this technique. One of the cool example of doing this is being used in self-driving cars as well. One of the use cases. Semi-supervised is like a mix of with level data and unlabeled data, which is a combination of supervised and unsupervised, and that is something which are very less exposed to us, but definitely not in the GATE syllabus. So these two things are not in the GATE syllabus. So rather than focusing on which are not the priority for us, we are going to put focus on these two. Make sense, guys? Cool. Now, I would also like to talk about a little bit on the program, right? So those who are interested, those who are aware of this program, which IMS is running, if I can go back to my screen, I can show you, right? So already we are doing live sessions, every day, right? So if those who are interested in going through this, a proper uh, detailed approach to the GATE preparation for data science, this is your link. You should come here, my dear. So if you see live online program, this is the link you can click and go through and understand. This is for the online program. If you look at this link, which is all given in the description, so if you go to the YouTube page, in the description, you'll see everything is mentioned. And if somebody is interested in an offline classroom program, they can click on this link. Okay, for test series, you have it when you are trying to prepare. It's important to write test papers, so you can click on that as well. And I'm going to share the details of the notes and everything which will come in the Telegram group. You can also join that group clicking on this link, and everything will be available to this group. So this is just for information which I wanted to give, that we are already running with the program, just to inform you or your friends that this masterclass is definitely give an idea that how we are going to run the session. But at the same time, if you are interested and you are already have made your mind, you can click on these links. Okay, quickly I'll jump to my next tab and we'll discuss the simple linear regression. Let me put the heading here. Simple linear regression, you know, this is one of the most famous machine learning models. And I think I have felt over almost 10 years of my experience that linear regression is the first algorithm anybody should learn. Okay, and without doubt, guys, right? This is one of the most easy algorithm to also understand, and you have been using some of those concepts related to simple linear regression, like for example covariance, correlation, right? And how to find the fitness of the data. So you have been using this in Excel or some of your maybe engineering first semester or second semester courses for some of the engineering stream. Simple linear regression is a machine learning algorithm coming from the category of supervised machine learning. Okay, now before we get into what is simple linear regression, I would like to introduce two terms to this topic: regression versus classification. Aditya, anyone, any idea? What is regression and what is classification? You will be hearing this a lot. Just to give an idea, simple linear regression is definitely having regression as one of the topic, right? Sorry, one of the keyword. When I'll talk about classification, I'll introduce another algorithm known as logistic regression. Might have heard about logistic regression as well, right? So what is the difference between regression versus classification? I would like to also call out here one thing, that it might seem that it's written regression, but it does classification, and there's a good detailing out I will outline. But for the time being, it can be a little tricky to understand. Oh, this is also regression. This is also regression. But if you look at the algorithm and outcomes, regression is going to give you a continuous output. So continuous Y. Okay. And if you compare classification, classification is going to give you a categorical output. So output is Y. Don't miss that. So for example, if you're doing forecasting, like for example, weather forecasting, might be aware of weather forecasting, remote sensing. Everybody has this app in their phone, which is called weather app. So looking at different parameters, right, you generate numbers on the weather, right? What is going to be the humidity for the day? What is going to be temperature range, from starting of the day till the midnight, right? Well, how much chance of the rain is going to happen? All those details you do, guys, isn't it? Come on, right? Everybody, that's correct. That's correct. Aditya, you're right. You are 100% correct. Classification contains categorical output. Okay, cool. So let me give you, yeah, let's go ahead. Let me give you this, a very simple screenshot from my phone, right? If you look at that, we are showing temperature range for the next 7 days. Can you see that, guys? You will see a continuous trend, right? A line is showing here. Let me highlight it. Can you see that, guys? So it is giving you the temperature, for the day. This is for Sunday from the time 12 p.m. till 9 a.m. What we are able to see here, right? Can you guys see that? So this is coming out of the weather forecasting. We are showing temperature, we are showing precipitation, we are showing wind. If you look at the Google weather as well, you will see. And then if you look at that, on the top, we have a for the day, approximately the wind is going to be 31 kilometer per hour, humidity is 67%, and precipitation is 10%. I know these are little tiny fonts, you might not be able to read, but let me voice over. Now, every day you get an idea that what is going to be your temperature, what is going to be your chance of rain. And these days, World Cup is happening, right? So you definitely want chance of rain to be like negligible, like 0% to 10% is the number we are looking at, right? I am sure that you guys are looking at the match which is going to happen tomorrow, Sunday. So there also, do you expect these things help? 100%. Nowadays, that's the reason that you are going to get a lot of ideas about the weather, how it will change, and that's the reason. If you look at, the tsunami, all different types of cyclones. These guys have got names also. We are able to predict in advance. Have you guys observed that? Experience? We are able to predict in advance and ask somebody who's living on the coastal areas like Odisha, or look on the other side, like those who are looking in Tamil Nadu, right? On the coastal areas, right? They are going to get a lot of alerts time to time that okay, these the weather is going to go for a toss. You're going to get a lot of high wind, and then the government and the NDRF, so there's a body which does look into these kind of relief fund, relief measures, right? So they're going to deploy their all the coastal guards and try to preempt that situation that people lives are at risk. Look at the beauty of such a amazing algorithm, right? You already know in advance, like 7 days, 10 days, that cyclone is coming. It will hit this coastal region with this much impact of the wind. What is going to be the situation there? They assess everything beforehand, and it gives them ample amount of time on their hands, right, on the table, that they can decide how to strategize and how to preempt the situation and save maximum lives. You guys agree with that? That's exactly that's exactly the power brings machine learning onto our lives, right? And look at these days, you are using a lot of AI based applications, as simple as using your camera, right? You are using forecasting. So look at the businesses which are doing retail forecasting, right? They know that how much demand is going to come for what kind of products, and in one way you are getting satisfied, right? Being consumers, let's say you are really needing some onions and chilies because you're making a morning omelette, and then suddenly you realize that okay, I don't have the onions in my stock. Like when you say your stock means like your kitchen inventory. So you just go to the Zepto or Blinkit, right? Just disclaimer, I'm not promoting any marketplace, but yeah, Zepto and Blinkit, you just order quickly, and they know that how much onion in which region is being consumed beforehand, and they match the demand and supply. So these are some real cool examples people are using as machine learning tool, and simple linear regression is one of the key algorithm there, right? Because you're going to predict continuous output, right? How many kgs of onion you're going to need, or what is going to be the temperature on the weather. All those things can be easily calculated with the help of linear regression model. I'll take a pause, guys. If you are good, then I'll get into the intuitive learning of, or intuitive idea about linear regression. As I mentioned earlier that, I'm not going to teach you linear regression in with the textbook kind of example. I'll show you some amazing cool ideas, applications, and understanding, so that you get a different flavor altogether, right? Definitely, I can quickly define what is linear regression. That's not a problem. But let's try to understand more like uh, in a layman term, that you don't have any idea about linear regression. You're looking at linear regression just like one. algorithm from machine learning, but what's the whole interpretation, right? So if I go to a very good website and just to give the uh, credit to these people, so it is coming from the Colorado University, and I'm going to show you an amazing intuition with the help of one example, an amazing example, which will be very easy to understand. And if I can take some data points, so if you're looking at these yellow balls, these are your data points which are putting on the XY axis, if you can see that. Look at here, guys. And again, I'd like to give credit to the university who has created this an amazing platform for us to visualize linear regression. So, guys, I'm not defining linear regression. I'm not writing any algorithm as of it. I'm not writing any formula as of it. I'm just trying to show you that this is how, let's say, uh, this is how x and y varying on a Cartesian plane. If you see, right, so you have some data points, as you can see, these yellow balls, right? And you're trying to find a line which is going to represent this data as close as possible, which in fancy word we say best fit line, right? Which we say in machine learning language. What is the line name, guys? Best fit line. So you're trying to find one line which is going to be as close to all the data points, right? So if you start with like one of my line, right? So let me show you this. This is my line. Now, intuitively, I'm trying to bring a line. Can you guys see that on the screen? One line I'm trying to bring. I feel this line should be somewhere here, right? So then you will be seeing that the distance from each of the data points, as you can see here, is trying to be close to this blue line. So what is the message here, my dear? If you look at the yellow balls, you have to move your line in such a way that ideally you will want every data points to be on the line, which can never be possible given the distribution. But if you try to move this line, you can take a simple straight line which is in the format of y equal to x plus b, which is slope point form. Slope is being controlled by this lever, as you can see on the screen, right? And the intercept, which is the constant part of the line, is controlled by this line, if you're able to see this. Okay. Now you're trying to move this line so that you are able to take most of the yellow line closer to the blue line, right? Yellow ball to the closer to the blue line. And if I try to show the error, you will see there's a tab called residues, right? So you will see that you are having the deviation from the line and the ball being calculated perpendicularly drawn these blue lines. Can you see that? And if you square sum everything and sum it up, it will start showing here. Guys, can you see that? This is what we call residue. I'll get into detail most probably in the next part. But residue and the square of residue, what is it, how we can interpret, forget about it. You just try to keep moving line that overall this guy, focus on this guy, follow my cursor, this guy should be as small as, right? Let me show. This is a really huge. Can you see that? Right? The sum is like going all the way till the end of the axis. If I try to move it closer, see, look at this, it is coming closer. Can you see that now it has reduced? So error is getting reduced, think like that. But at some point, it will be coming closer, right? Look at that. So intuitively, if you try to do that, it's very tough, difficult to find a line which is the best fit line. So that's where intuitively you can just do eyeballing, try to look at the error with the help of this tool, but still it's impossible because the line can be infinite, right? You need only one line which can be the best fit line. That's where we go on the left hand side of the tool, and there we will say best fit line. See that? Almost we were close, guys. This is good, right? So at least our approximation, looking at the eyeballing approach, we were able to go closer because the red line, if you see, this is the best fit line, right? And I can also calculate their residues and see, except few boxes, if you see, we are more or less close. Even look at the equation, y equal to 0.91x plus 0.20, and we are almost close. But let's say intuitively you are trying to do and you are a little far, or you did make a mistake. Can you see that now it has more error than the best fit line? Now, why best fit line is the most optimal line for us in this particular example? Because it doesn't take any line. It will test all the line which can be possible and tries to minimize this error. So mathematically, we are going to differentiate and find the minima of the error and then come up with the coefficient, which is your 0.91 and the constant. I'll take a pause. Aditya, everyone, are you able to follow this? Did you like this example? I've also taken the screenshot and placed it here, guys. So if you see, intuitively, machine learning algorithm linear regression focuses on finding the best fit line, right? It tries to get you the line which is most closest to the data points which you are seeing there. Okay? And how we are going to do that in when you are going to actually understand machine learning algorithm linear regression, you are going to find some relation between the input and the output. Okay? Make sense? Now, let me define linear regression, guys. So linear regression, okay, there's a question from Aditya. Are we trying to minimize the error? That's correct. And Aditya, if you vaguely remember, there's a concept of OLS. I hope you somehow remember that. So what is OLS? OLS is ordinary least squares. Do you remember? So this square itself is your error. Okay. Least means you will try to minimize it. So minimum, you want to minimize the error. And error, we are also going to put in a fancy language, residue. Ideally, this error is not going to be just residue. Later, you realize that it is square of residue. That's why this square is there, right? Square of residues. Okay, maybe I'll just find some space here, right? So that's where you're right when you say that are we going to minimize the error? That's 100% correct. But now there are different approaches to it, right? Are you going to do a simple square of error and minimize it? So that's where you will combine these two guys, right? Ordinary and ordinary least square. But there can be different approaches to do the, to find the best fit line. Ordinary is like a vanilla concept where we don't do anything extra. We just go with a simple mathematical square of the error and try to minimize it. But as course unfolds and for detail, definitely that's where you have to join the program. There we are going to talk about different methods of getting the best fit line. And in some data set, ordinary will do a great job. In some other data set, right, where the relationship can be a bit of non-linear, right, you are not going to use our OLS method because that is only reserved for linear regression. For some non-linear regression or non-linear kind of data behavior, you have to use some other techniques, and that will not be vanilla ordinary, it will be different. Okay. So on this note, guys, let me define now, if we can move ahead, and let me define what is linear regression. So linear regression, I really like to write, guys, so I'm not showing you any slides here. Linear regression is a technique of finding the relationship between two or more variables, right? Two or more variables. Now, if you look at linear regression equation, which is written as y equal to beta naught plus beta 1x, okay? As of now, I'm taking a simple linear regression, which is single variable. Can you see that? X is your input variable. X is your input variable, guys. Beta 1 is, excuse me, Beta 1 is your slope or coefficient. Slope or coefficient. And beta naught is intercept. Let me write. And generally, when you are trying to do this, you will be always be relating this equation with y equal to mx plus c. So c plus mx. Now you can clearly draw a similarity, right? See, c is more like equal to beta naught. M is more like uh, is beta 1 and x is x, right? Now what is y? Y is your y is here is your, come on, target variable. What is y, my dear? It is target variable. It has gotten different names like output, you can also call it like dependent variable. All these are valid names. Okay, just like input variable can also be tagged as like features, right? Feature or independent variable. So all these names are valid here. These are all synonymous. So far so good, guys. Are you with me? Any question, guys? No? So now if you look at this example, if I go back, right, and if you extend this example to our recent example where the tomato prices increased drastically. Remember that? I think there were a couple of months when tomatoes were really high, right? So tell me one thing. If tomato demand is increasing and supply decreases, okay? So let's say any commodity, not only tomato, but if I ask you a simple question, why prices increase for a commodity? Why gold is expensive and aluminum is not, right? Why? So a little bit on the business side, if you look at it, right? If you model Y price for the tomato, that's your dependent variable, okay? And you are putting in the form of a linear regression, but this time I'm going to take, multiple variable linear regression, right? So you have two variables, demand and supply. Now you tell me if demand increases, so I'm increasing the demand, and supply decreases, then what will happen to the price of tomato? You tell me this. Price of tomato will also increase drastically. So are you able to see that there is some relationship? Hello? Guys, are you able to see there is some relationship? Price of tomato depends heavily on demand supply. And if you are aware and you were following up on this news that tomato prices are increasing because a lot of tomato crop, right, it got damaged because of the weather scenarios. So we could not meet the expected demand or expected inventory of tomatoes, and that actually started increasing the price for tomato because supply definitely gone for a toss. And that's where I think Indian government they intervened and they tried to import tomatoes, and that's where they control this scenario, if you are able to follow this, isn't it? Okay, what you are looking at, this is an example of what linear regression? Multiple linear regression. So I have shown you both the flavors of simple linear regression, which I was trying to explain with the intuition on that website example, if you remember, right? See here. Yeah, see here. So where I has only one variable called x, right? And here we had y. And that's where the best fit line equation is being shown here. Clear? Okay. Now, if we are good, I'm looking at the chats if there are any questions. Guys, feel free to ask questions. Okay, so if there are none, I will move on to the next topic, which is linear regression terminologies. Okay, so I'm going to show you a nice diagram. Let me do that. Maybe we just need this axis. Perfect, guys. And now if I draw a line, hold on, guys. If I draw a line, see, and then let's say we have certain data points. Yeah, let's say we have certain data points. I'll put data points quickly, guys. There are data points like this. I'm just taking a simple example, guys. Okay. And this is just for illustration. So don't pin me with this, that, okay. This is not the best fit line or the best fit line. I'm just, drawing with my bare hands, right? So don't pin me on this, that, this is not a, the best fit line. So can you see that these are your data points? The red dots are your data points. Okay. The line you are looking at is your linear regression line. So let me write here. This is a known as least square line, or you can simply say linear regression line. Okay. So this line is coming as an outcome of your machine learning algorithm. Okay. Clear? Now, if you look at the errors, right? So if I start drawing the, this, okay. So you will realize that all these which I'm drawing perpendiculars, right, on the line is known as what, guys? Residues. So let me, maybe we can focus on one. So we can say this is the residue, right? Let me write here, this is your residue. Now, what is residue? You have to define. It is the difference between the actual value and the predicted value. So what is your actual value? This data is your actual value, right, guys? This is your predicted value. Let me put a dot here. This is your predicted value. This is what you have predicted. Y hat. This is what? This is your actual value. You can call this as Y, and you can call this as Y hat. So if you find the delta between these two, that becomes your residue. Are we clear on this, guys? Now we will also be looking at this thing, which is your from origin to this data point where the intersection is happening, this line intersection. This is known as your beta naught, okay? Beta naught, or your intercept, okay? Now, if you pick this line and try to, find beta 1, so beta 1 will be equal to, let me write, beta 1 is equal to dy by dx. So basically it is slope, right? So we'll differentiate, and I think you are aware that differentiating y with respect to x gives you the slope, right? Clear, guys? So now on this particular example, if you have any question, guys, let me know. So beta naught. I've already explained what is beta naught, right? I have already explained what is beta 1. Now you know what is residue. I'm highlighting as well so that you don't miss on it. You have the actual line, right? And then you have the data points. That's what you look at any particular linear regression plot, which is a simple one. Cool. Any question, guys? My eyes are on the chat. Any doubt? Any question? Now, I will end the today's session with a question that why do we use OLS? If you recall, I had explained very high level, ordinary least square. Question is that why do we use OLS? So next session in the series will start with answering this question, and you can, and those who are the viewers or the learners who is currently watching this session and they might watch between today and tomorrow, please comment in the chat that why do we use, I missed to write use, why do we use ordinary least square? Any reason for it? OLS technique in linear regression. Aditya, you have any answer for the day today itself? OLS is, guys, ordinary least square. It's a technique. Why do we use it? Okay, that's the question I am asking. Perfect. So work on this simple question. Try to do a little bit of reading. You can also search on the web. Come up with that. You can directly put in the chat. I think somewhere today around 10 p.m. or so, I'll come visit and see the link again and see that if somebody's answered, and maybe I will reveal it. But I think I will spend my almost 50% of next session on why do we use OLS technique, because to answer this question is really important to understand that why, what are the other techniques which could have been used, but why did we discard them? Why did not we consider? Because every other technique will have some issues, which I'm going to divulge further. And guys, just to come back to the GATE paper again. So guys, again, I would try to encourage and motivate you guys that this is a golden opportunity for anybody who is in second year, even first year student can attempt and can start preparing. Given the scenario we live in, the job scenario, you might be reading a lot of news on the IT service industry, right? They are not recruiting, they are not doing a lot of normal behavior is not being expected this year, next year. So that's where I would like to encourage, and you can read a lot of news regarding the same. As simple as that, I can say Infosys, I can name it here, and that's out in the public. You can read that Infosys has planned to not recruit anybody in the IT side, like software quality tester and all those kind of jobs. So then it becomes really important for us to be alarmed, being a student in college who are in second year, third year, or maybe final year, and plan your career meticulously. Else, things can go really for a toss. We are not living the ecosystem as of now in terms of job is not really great, and there are means multiple reasons to it, nobody to get blamed for. So that's where gate has given you a silver lining in this dark cloud, and try to pick it up the signals which we are coming on this platform, which IMS is trying to give you, and take it like a real serious signal for your career. Don't take it lightly. I'm trying to again highlight this fact that this is a serious situation we are living in, and given you have spent quite a lot of money in your education, your parents are doing that, it's important that you complete focus should be on the gate paper. You try to have some options on the table. Don't procrastinate, don't keep thinking about that, we'll see in third year or final year what happens. And those who are already in third year, final year, I think you know what to do. So on this note, guys, thank you very much. I will be talking about more in this series. Come to this session tomorrow same time. I will be meeting you guys again, and we'll try to meet more frequently if you guys keep encouraging us, keep supporting here. And if you have any question, you can put it in the chat. I will take one question from Aditya Rao. Aditya is telling, I haven't learned about OLS. I have learned gradient descent approach of solving the regression problem. Very good, Aditya. That's correct. But definitely that is another technique. And I was telling, right, OLS is just one of the technique and the very basic and fundamental way of learning linear regression. once we go into the details, and I think I'm afraid which will not be able to cover everything here, but in program we definitely touch base upon gradient descent algorithm. That is another algorithm uh, we do uh, where we are going to use gradient descent GDA we call to solve linear regression problem. But there are other as well. You must have heard about RIS, Lazo. There are a lot of tools and techniques with respect to regression. So that's all from my side. Anything else? I see another question from Aditya. Uh, I'm a little bit confused as I'm pursuing master in data science from Central University. Should I focus more on GATE exams or project? I think, see, GATE exam is not only an exam for education. Always remember that, Aditya. Uh, I have been teaching GATE for 10 years now. So GATE is your gateway to jobs, career, everything, right? It's not only for MTech or MS, but suppose you are able to clear GATE in this paper, you can also enroll yourself in other jobs programs, like PSUs are offering a lot of jobs basis some GATE scorecard and some more criteria on the written test or the interview, which we can definitely talk about later. But it's just not about only higher education. Always remember that GATE always provides minimum two options. There are more than that. Number one is definitely higher education, which we always encourage everybody, because once you get into IITs, right, your whole perspectives about life and career change. So that's the golden opportunity. I always encourage all the students to go for it. But let's say you want to directly go to, go for a job, you want to just take care of your financial things. PSUs is one of the best option on the table, where you can, I have seen a lot of CSITs, PhDs are also picking GATE students, and they're also having a lot of jobs in data science field, which team can always talk about in detail. You can contact, and that's where again I would like to highlight how to contact them so that you don't miss this, uh, because they will be with the right person to deal with your confusion, and that's where you can click on this link, Aditya, as you can see here, right? So if you see live online or classroom program, any of the links you can click and try to go into the details. Make sense? Okay, so I think, yeah, it was really nice talking to you guys. I think we have just started on this. The second session onward, we'll get into too much of the details which you might be looking out, right? I'll talk about mathematical formulation of linear regression, and we'll do some quick examples, what kind of gate question they can ask. So we'll try to solve some of the good gate questions which we feel they will ask, right? And then we'll conclude our linear regression. So just to repeat myself, guys, on this, I will be starting with OLS. I'll answer in the next session, which is the series, second session in the series, part 2. Then I'll go into the mathematical formulation linear regression, which I basically mean that I'll calculate beta naught and beta 1, mathematically derive it by using ordinary least square technique. And fourth session will focus more on what kind of questions, what kind of interpretation of the algorithm we should have to make, what is the generally the outcome. Maybe I'll show you an Excel example of doing linear regression, and depends on the time, and show you how to interpret the results and what kind of questions GATE might ask, which we are anticipating with our experience and exposure. So with all that, guys, thank you very much to be being in the session. Keep encouraging us, keep supporting us. Thank you very much, guys. Bye bye.